Hello students. Now I want to give you some explanation about electric field intensity E bar due to infinite surface charge. This derivation is somehow similar to earlier equation as we learned electric field intensity E bar due to infinite line charge. Here we have considered infinite line. The length of the line is infinite, plus infinity to minus infinity. Here we are assuming a particular surface. It is having infinite surface area. Okay. Right. Here we are assuming the point P 0, 0, Z on the Z axis. Here the point P means here it is the point at which E bar to be calculated on Z axis. I mean electric field intensity due to infinite surface charge at point P 0, 0, Z. We are considering this infinite surface charge, infinite surface on XY plane. I mean generally it look like a front view, but this infinite surface is in the bottom view. Okay, like this differential part. Among this infinite surface charge, I am considering this selected part, nothing but ds, differential surface, and it having the radius is from origin to ds rho as rho. In general, coming to cylindrical coordinate system, once we remind the things what we learn in the cylindrical coordinate system. Here in cylindrical coordinate system, the point is r comma. Here the point is okay. Here the point is P of r comma phi comma z. But here we are considering here in place of r we are considering rho. We are considering rho. Okay, and phi is as it is. Okay. Here in place of r, we are considering rho. Okay, right. From origin to ds, we are considering radius as the rho. Right. Okay. ds is the differential surface, and it is carrying the charge dq. Okay. As we know, rho s means s represents surface and rho represents charge density. Surface charge density is equal to ratio of charge and with surface q by s, dq by ds. So from this equation we can write dq is equal to rho s into ds. Dq is equal to rho s rho d rho d phi. How this equation has been written? Okay, here rho s is rho s, dq is dq, and in place of ds I am writing rho d rho d phi. Okay. Here we can write in general we know ds is equal to meter into meter, right? Okay, and here the first meter means x-axis and y, because we are considering the surface infinite surface on xy plane. I mean we have to consider rho and we have to consider the phi. Okay, r direction, I mean rho direction, phi direction. Here the rho direction, the length meter is dr. Here we can write it is equal to dr, and phi direction we can write r d phi. Okay, but we are replacing, we are considering rho in place of r. Here we are considering rho as the radius of the cylinder, so we can replace r with rho. Here d rho means dr means d rho, r means rho, and d phi means d phi. Okay, again reframing, rho I am writing front and d rho d phi. So I am replacing ds is equal to rho into d rho into d phi. This is the equation what I reckon. Rho d rho into d phi, ds place lo rho d phi rasan. Okay. Next, we have to find out electric field intensity E bar. As we know, E bar formula, dE bar is equal to dQ by 4 pi epsilon naught R square R bar. Okay. Here from equation 1, we can replace dQ with rho s, rho d rho d phi. As it isly I am writing. And denominator as it isly I am writing 4 pi epsilon naught R square R bar. Okay. Right. Here AR bar is the unit vector and R is the distance vector. Here R is the distance vector, AR bar is the unit vector. Okay, I am writing this right angle triangle here like this. Yes, here it is R bar and here it is ds, and from origin to ds the rho distance is rho and unit vector is a rho bar. So rho into a rho bar, nothing but rho bar. Similarly, the length it is lying on the z axis. Okay, here the length is z, and the unit vector here, the unit vector is a z bar. So it is z bar. So r bar is equal to, we can write r bar. Okay, here from ds the direction is from ds the direction is ds to p 0 comma 0 comma z. So I'm writing the direction from ts to p like this. So we have to subtract from this direction, from this vector, rho vector. Okay, that is r bar is equal to here the direction is r bar is equal to z bar minus rho bar. Here z bar is nothing but z bar minus rho bar. Okay, r bar is equal to z bar minus rho bar. Okay, this is the equation what I written here. From this r bar vector, we can write mod value, nothing but coefficient square. So minus rho square, nothing but rho square. Z square is nothing but z square, root of r square plus z square. And AR bar is the unit vector, the ratio of the vector by mod value, r bar by mod r. Minus rho bar plus z bar by mod value, root of rho square plus z square. Consider this as equation 3. Okay, from equation 3, okay, we can reframe the equation 2 as like this. dE bar is equal to rho s rho d rho d phi by 4 pi epsilon. As it is I am writing. In place of r square, I am writing rho square, root of rho square plus z square whole square. R square is also, as we know, I said many times, mod of any vector is equal to scalar value. Mod or any vector is equal to scalar value. So mod r is nothing but capital R. Mod r bar is nothing but capital R. Okay, I am writing here itself, no problem. Okay, so in place of r, I am writing root of r square, rho square plus z square, and r square means whole power 2. Okay, and a r bar in place of a r bar from equation 3, in place of a r bar from equation 3, I am replacing this equation. Okay, integrating on both sides. So on left hand side, the differential will gets cancelled. So dE bar becomes E bar. Okay, and right side it becomes, here the differential terms are two terms. One is d rho and d phi. D rho and d phi. D rho having the integral rho, it is the radius of the cylinder, and here we can write there are limit, radius of the cylinder having 0 to infinity, and phi having the limit 0 to 2 pi, azimuthal path, complete azimuthal angle. Okay, so radius rho is equal to 0 to infinity and phi is equal to 0 to 2 pi. And rho s rho d rho d phi. Rho s rho d rho d phi 4 pi epsilon naught r square root of rho square plus z square whole square. As easily I am writing. Simply I am integrating. I am writing two integrals. One is a rho integral and another is a phi integral. Okay. Here I am ignoring a rho bar component. Here I am ignoring a rho bar component. So if we simplify, if we continue the a rho bar term in the until the last step also, when we have to replace the limits rho is equal to 0 to infinity, upper limit is infinity, lower limit is 0. Infinity minus 0, nothing but here it becomes infinity. So infinity into a rho bar, it is also infinity. So we don't know the value of the infinity. So we are initially ignoring a rho bar component in this equation. So the entire equation becomes, the numerator becomes only z a z bar. The denominator is whole power 1 by 2. Here the square and root gets cancelled, whole power 1 and 1 by 2. A power m, a power n, a power m plus n, 1 plus 1 by 2, whole power 3 by 2. Okay, in this in the line equation also, infinite line also, we have ignored one z component. We have ignored the z component. Okay, similarly here we are ignoring a rho bar component, rho component. Okay, right. Finally this equation looks like this. Okay, and to simplify this equation, I am considering rho square plus z square value as u square constant. Rho square plus z square constant is equal to u square constant. Okay, taking derivative on both sides with respect to rho and with respect to u, and z as a constant. So rho square becomes 2 rho d rho, and z square, it's a constant, becomes 0. Okay, and u square becomes 2u du. 2 gets cancelled. Finally rho d rho is equal to u du. We can replace this equation wherever we need. Okay, and here I am changing the rho limits 0 to infinity. Here the rho lower limit is 0 and upper limit is infinity. First of all, substitute rho is equal to 0 in this equation. Then it becomes 0 square z square and u square. 0 square plus z square, nothing but z. Z square is equal to u square. Square gets cancelled both sides. So finally z is equal to u. And similarly, we have to replace the upper limit. Rho is equal to infinity. Okay. In place of rho, I am writing infinity. Infinity square plus z square is equal to u square. If infinity square, infinity. If we add anything to infinity also, it becomes infinity. So infinity is equal to u square. Square, when it comes left side, it becomes root. Root infinity also infinity. So infinity is equal to u. So we have to replace the rho is equal to 0 to infinity as u is equal to z to infinity, like this. U is equal to z to infinity. Here also in the infinite line equation also, we have changed the z limits to theta limits to simplify the derivation. Here we replaced rho square, rho equation, rho limits with u limits. U is equal to z to infinity. Okay, and rho s is rho s. Rho d rho. As we know from here, rho d rho is equal to u du. So I am replacing u du into d phi. The denominator 4 pi epsilon naught, 4 pi epsilon naught, and rho square plus z square is equal to u square. So I am writing u square, whole power 3 by 2, whole power 3 by 2, and z into az bar, z into az bar. Okay, by simplifying again, okay, here rho s and u du d phi and 4 pi epsilon naught, 4 pi epsilon naught, u square and 3 by 2, the denominator 2 and square gets cancelled, whole power u cube into z a z bar. U gets cancelled, u cube with u square times. The denominator, 1 by u square whole power, that becomes u power minus 2. U power minus 2. Considering rho s value and 4 pi epsilon naught value as constant, I am writing front. Rho s by 4 pi epsilon naught integral 0 to 2 pi integral u is equal to z to infinity u power minus 2 du d phi z a z bar z a z bar. Okay, if we apply integration to u power minus 2 into du, then u power minus 2 it becomes minus 1 by 2. Okay, upper limit is infinity, lower limit is z. Okay, if we apply integration to d phi, it becomes derivative integration gets cancelled and becomes phi, and upper limit is 2 pi and lower limit is 0. Z a z bar z a z bar. Okay, and rho s 4 pi epsilon naught rho s by 4 pi epsilon naught. Okay, substituting upper limit, so minus 1 by infinity minus lower limit minus 1 by z, minus 1 by z. Okay, and here the substituting upper limit 2 pi and lower limit is 0, so 2 pi minus 0 z a z bar z a z bar. Okay, minus 1 by infinity, anything by infinity is we can't define the value, so we are ignoring minus 1 by infinity value, and minus of minus 1 nothing but 1 by z. This is the 1 by z. Rho s by 4 pi epsilon naught rho s by 4 pi epsilon naught. 2 pi minus 0 2 pi z a z bar z a z bar. Okay, 2 pi gets cancelled with 4 pi 2 times, so rho s by 2 epsilon naught into a z bar, and here the z gets cancelled, z gets cancelled, so it is unit is volt per meter. Okay, and E bar value is positive when we consider the points above xy plane. Here the point P is above the xy plane, so E bar value equation becomes positive. If we consider below xy plane, the symbol changes to minus. If we consider this P point below the xy plane, so like here, then the equation E bar becomes negative. I mean minus rho s 2 epsilon naught a z bar. Okay, for any, not only for a z bar, considering any unit vector, we can replace a z bar with a n bar. Finally, E bar is equal to rho s by 2 epsilon naught a n bar. This is the finally electric field intensity due to infinite surface charge. Okay, thank you.